Hello, welcome back to part 3 of the Excel Eve case study, and we are going to be wrapping this case up by finishing level 7 and the bonus questions. So as you can recall from last episode, we finished up level 6, which has us essentially having the mining barge travel across our asteroid field map, mining the asteroids and figuring out how much money we get. So level 7, the question here is, on level 7, you need to combine your skills at mining and manufacturing. 50 asteroids of various types have spawned in your home system. Your goal for each game is to calculate how many griffins and thrashers you'll be able to manufacture out of the minerals mined from these asteroids. First, you'll need to use all the minerals to produce as many thrashers as possible, and then use all the remaining minerals to produce as many griffins as possible. Each game also has different mining skills for each type of asteroid. So essentially, we need to output an answer that's how many thrashers and how many griffins we can build. The good news about this is we don't have to worry about our mining barge, because we're assumed to be able to mine everything from kind of these asteroids, barring our mining skill waste there. So right off the bat, we can see, okay, so the tricky part here is, once again, we're going to need to pull out the asteroid type, because it doesn't give us the asteroid type, it just gives us the background there. So what we're going to do is we're going to just copy the 50 asteroids here. Whoa. I thought I copied the mining and allowance as well. Nope. Okay, so we're just gonna paste here. And then we're gonna say asteroid background color. Okay. So this way, we're gonna kind of, if you recall, we had this macro that essentially help us kind of identify the background colors here. So essentially what we're going to do is we're going to modify this so that we're going to change the row and the columns so we can pull the background colors of all of these thingamajiggies, asteroids there. So we're at row 296 and we need to go all the way down to row 327. So 296 to 327, right? 296 to 327. So 296 to 327. And then for column 1 to 50. Next column. Okay, cool. So now we need to figure out what is the first row color, and that is row 14 or column 14. So row, we have column 14, which would be 13 plus our column variable. And then we need to spit out that color to here, so we can match things up nicely. And that is 65. 65. So essentially it's 64 plus column. And that is all we need to do. I'll just rerun this. Takes a while to run. We'll pull. There we go. And let's see if that did it correctly. Perfect. So now we get all of the kind of asteroid background colors here. So we're going to just copy here, paste here. And then we're just going to put asteroid type. And this will be just an easy lookup of this. We need the asteroid background color and the asteroid. Make all of these static. And we got our asteroids for our field that we need to mine. What row do we go down to? We go down to 327, huh? 327. There we go. Cool. We got our asteroids in the field that we need to mine. So now what we need to do is figure out how many units of each of these asteroids we have. Because essentially we want to calculate based off of the units how many asteroids we have. So let's just do units of asteroid we have. So there's only 4 different types of asteroids. So we have Feldspar, Skordite, Amber, and Carnite. Right? And then essentially what we have is a simple sum, right? So we want to make sure if this equals Feldspar, we want to sum up the number in here because that gives us the thousands of units of the particular asteroid. So equals sum if, and then we're essentially looking at this range, and we'll keep the columns static. And for the criteria, we want this criteria, and we'll keep the row static. And then the sum range is going to be the value in this mining allowance, and we'll keep kind of, once again, the column static here. So that gives us the total. But remember, for units, what we need is we need to multiply it by well, we could just do the multiply units in thousands of the asteroids. Okay. But the other thing we need to do now is we need to, when we put this across, we realize that we need to factor in the waste. And the waste, since we're doing it in exactly the same order, is really going to be pretty easy because it's just going to be this value times that formula, the 0.75 plus whatever this is, times 0.05. And that should give us the actual kind of total thousands of units with the waste accounted for. Cool. So now we just bring this down. And we have the unit in thousands of the asteroid. And now what we can do is get the total ore mined from asteroids. And we need to grab our 4 types of ore that we care about. So what are the 4 types of ore? I can probably just go to my reference. Here they are. All the way across. 4 types of ore. And then what we pretty much want is the Feldspar has, let's see, 400 tritanium, and the Skordite has 150. So essentially, this is just going to be some product of this times what we have in the tritanium column. I don't know if I'll count these as zeros, but hopefully I'll consider blank fields as zeros. And then what we need is to multiply that by 1,000 just to get the total units here. And then Fk to Fn needs to be static here. And then 2 to 5 needs to be static here. because then we want to grab the pyrite, mexilon, and isogen here. And then we just drag it all the way down, and we can get the total amount of ore mined from our asteroid fields existing. So we're pretty much done, surprisingly. Like I said, this level 7 is surprisingly a lot shorter than level 6, but then we need to figure out the number of thrashers we can build from kind of this list. And what I'm going to do is I'm just going to take a look at each individual mineral and calculate just based off of that mineral alone how many thrashers we can build, and then take the minimum of 4, because that way we can guarantee, let's say you could build 1 thrasher based on the tritanium and like 100 based off of the other minerals, then you can for sure build 1 thrasher, but that's it, right? Whereas, yeah, so essentially that's how we can calculate the max number of thrashers we can build based off of the minerals. So the easiest way, I guess, to do this is just to round down, because we can't make a partial amount of thrashers, and then we essentially need to do this divided by kind of the thrasher cost in tritanium. So we need to do a XLOOKUP. Specifically, we need to look up the thrasher. Actually, no. All we need to do is we just need to go to sheet 1. We just need to do XLOOKUP this. Oh, nope, we need to look up the tritanium, and then we need to go here. Yeah, so let's look up the tritanium. And then look up this, and then return the thrasher amount here. So we make this static be, yeah, we need to make all of this static. Another parentheses at the end. And round down needs 0, 4. Okay, so now we get our calculations for the ships, and we can just drag this down, and we got the total number of thrashers that we can build, essentially. So now we actually get the actual thrashers made, and that's just going to be the min of these numbers. Cool. So now what we need is we need to get remaining or after making thrashers. So essentially what we get is we need to do equals this minus this times XLOOKUP of the cost of the thrashers in tritanium. Whoops. Let's actually do the tritanium first. And then we will find the tritanium and we'll pull that thrasher list. And then we will kind of, once again, make certain things static. Then we want this to be dynamic. That times lookup, we want that. I think this is what we want. We're getting negative numbers. That can't be right here. So taking this minus this times this FZ isn't needs to be static here. So I think that fixes it because we're only looking at the thrashers made in this column. There we go. That looks about right. And then we'll just drag this down. And we have the remaining ore after making thrashers that we need to use to make griffins, I want to say. Griffins, okay. So now we just need to calculate number of griffins made. So number griffins, I don't know how to spell it, we can build. So we essentially, my plan is just doing the same thing. Grab this. Oh. Down. This X look up. The tritanium cost of the griffins. So the griffins is going to not be B3 and E3. The griffins are going to be B2 and E2. So we're just going to need to modify this formula to B2 and E2. And then we can pull this across, pull this down. And then once again, do a actual. Griffins. And we do griffins. I think there's an H or something. Griffins. And so essentially it's the min of this value. And then we grab it down. And then we go to actual answer, which is equals to concat key with the number of thrashers made, and then G with the number of griffins made. Oh, what happened? G with the number of griffins made. T268G1. T268G1. There we go. And then all we need to do is copy this down. Copy and paste. Boom. There we go. And that's 1,500 points. And now we can work on the bonus questions. So that's pretty much all of the main cases. When we go back to the bonus questions, we can see that it's going to refer to a lot of kind of previous things that we did, right? So it should be not too difficult. So for bonus question 1, how many cubic meters of umber do you need to mine to have enough pyrite and isogen to produce a megathron, assuming no waste? Provide your answer in M3 cubic meters. So Umber. So we need to take a look at Umber and the Megathron kind of connections. So Umber gives 90 pyrite and 75 isogen, right? For every 0.6 cubic meters. And in order to build a Megathron, we need 4 million pyrite and 400,000 isogen. So let's just kind of take these two numbers, plop them down here. So we need pyrite and isogen. And then we have Umber that gives 90 pyrite and 75 isogen for 0.6. cubic meters. So we need 90 and 75 isogen. So a really easy calculation to do is we can figure out how many cubic meters or how many units of this asteroid we need in total in order to produce this much pyrite and this much oxygen. So it would just be this divided by 90 and that divided by 75. And clearly the pyrite is a limiting factor, right? Because we need for this many units. So it would just be this times the 0.6, and we can round this to the nearest integer. And that should be the answer that we need for the volume of Umber that we need. Cool. Simple enough. Let's do it. What's the cheapest production cost of a Drake in the month of October? And provide our answer in the nearest thousands of ISK rounded to the nearest integer. Okay, cool. So essentially, we want to figure out the cheapest production of the Drake in October. So let's get rid of kind of the scratch work we did here. And let us go into the month of October. And so I'm trying to figure out exactly what I want to do for listing out all of the months here. I think the best thing I want to, or the thing that I want to do here is I want to go with the dates across the top. So October, so that would be 10/1/2023. And all the way to 10/23. I don't know how many. Yeah, must be 10/23. We'll just assume Excel knows how to do the dates. And then we'll need to grab the cost of all of the minerals. There we go. Titanium, pyrite. And so essentially what we need is just a lookup of kind of the minerals prices here. And so essentially what we can do is just copy this. And because we have already used the formula, we can just transpose. And it should do exactly the same thing except go sideways. And so now we can just take the prices of these minerals and just go right across here. And we got all of the prices in the month of October for kind of the ship. So now what we need to do is figure out the cheapest production of a Drake in the month of October. So what we need to do is figure out what a Drake costs. So here's our Drake. Right? And so essentially, how I'm going to interpret this is we're buying all of the minerals at once. So it's not like we're buying the titanium at one price point and then the isogen at a different price point and that sort of stuff. And so if we're buying all of this at one price point, we're going to just transpose this, because that way we can just once again do what we like to do the most, do a sum product across the Drake. So this would be the total cost column. And essentially that's just a sum product of these columns with these prices. And I think we need to make sure that this stays static, huh? What's the best way just to organize this? Let's move this down to the side, get rid of this, and move this here. So we got the total cost, and we also want to make sure that this is not going to change. We are forever going to be looking at this, even if we drag the row across. We want this 52 to 58. There we go. And then we just drag this all the way across to figure out all of the price points of building this Drake. And now we need to factor in two remaining things. One is the 10% markup and thousands of ISK, right? So essentially we want, let's just figure out the minimum cost, which is this. There we go. And then we'll give this a 10% markup and then divide it by 1,000 and then round this to the nearest 1,000. So 58687. Correct. Okay. Problem number 3. So now this one's a little bit trickier. So this is if you buy, let's get rid of, so if you buy one Megathron chip on any date in the given range from May 1 to November 27 and then sell it for profit, what's the maximum profit you could have received? And provide your answer around to your nearest million of ISK. And notably, you cannot short sell. You need to buy first, okay? So once again, this is pretty, or it's going to be a little bit more complicated, but not by much. So we're just going to go ahead and get rid of some of kind of our data here. And what we want is we want to start with the first date. So May 5th, I want to say, 2023. And we essentially want to pull it all the way to November. I don't know how many dates we have. November 27th. There we go. So we have all of the dates here, and we're going to hold price points of all of the minerals for these dates. There we go. Okay, so now that we have the price points of all of the dates, what we need to do is figure out the cost of the ship, right? So cost of the Megathron. And once again, just like in the previous problem, we're going to pull this information and we're going to just transpose it. And we're going to do equals sum product of this and this. And we're going to make sure to make things static. And we got the cost of building a Megathron. Cool. The one other thing I want to think about is let's incorporate the 10% producer markup price for creating a Megathon chip right off the bat, because that way we don't have to worry about it in any of our future calculations. So we got the price of this chip across all of the dates in that we need, right? So now what we want is trying to figure out, so essentially at each low point, right, we can be considered like, so for example, we start here, we buy the ship for this cost. If the next date is higher than or equal to our lowest point, then we could potentially sell it for some profit. But if it ever dips below the price that we bought it for, that kind of essentially becomes our new low point that we could buy the ship for, right? And so what we can say is we could say the minimum price point that ship could have been bought as of date, right? So for example, here, like the minimum is obviously this date, but in the future, we're taking a look at if this value is ever less than kind of our original minimum, then we change our minimum to reflect the new minimum date. And so essentially, yes, let's just try this. So the first is just going to be equal to that. This is equal to min of either this or this. And if we just drag it across, we should have the minimum price points that we can buy the oh, I see. There is an NA date. So September 1st and September 2nd, there is no dates there, which is kind of awkward. But we can just delete those two dates because we don't need it. Here we go. Awesome. So now what we want to do is calculate the maximum price we can sell ship given minimum buy price, right? So essentially here, what we're saying is if the minimum price is kind of is consistent, then we're going to take the maximum of the this price and this price. So for example, if this is equal to this, then we're going to take the max of the cost. I think it's just of this and this. And otherwise, we just take this. So let's see if this makes sense here. So if these two are equal, we take the max, and then otherwise we just take the minimum price. Let's drag this across and see what we get. Cool. It definitely looks like it reflects the highest price Oh, whoops. Nope. It's good to check. So no, we want it to reflect the max of 59 or 61. Otherwise, we just take, 60. Here we go. Let's see if this makes the formula a little bit better. There we go. Yeah. So now we can actually see essentially what the highest price is here, right? And then now what we need to do is grab the price differential. So price, which is just equal to this minus, or I guess maximum minus minimum. Oh, don't need parentheses. Drag it across. And then we just calculate the max. Equals max of these values. Cool. So we got the max gain, and then what we need to do is we need to round to the nearest million of ISK. So round this, divide 1 million, 0. 49. Cool. Awesome. So compare the value of the 4 asteroid types using this case study on November 1st, 2023. What is the highest value ISK on November 1st, 2023? Okay. I mean, didn't we kind of do this for case or for the to try to calculate traveling and the rank here, except we just need November 1st, right? I mean, I don't see how this is different. And we want it by meters, cubed. So why don't we just copy this down? Whoops. So we can just drag these values down. And then we want, what's the highest value? Round to nearest integer. This seems to be the highest value. So we just paste it and round it up, right? There you go. Pretty easy. Yeah, bonus 4 was really a gimme. So bonus 5, what's the total remaining unmined amount of asteroid ore in cubic meters across all games on level 6? So essentially what we want is the total remaining unmined asteroid on game 6. So let's take a look at level 6. So we have all of this stuff. But see, notice how there's a bunch of unmined asteroids. And the tricky part is if all of the unmined were full, that's fine. But we have a bunch of asteroids that we partially mined. So we also need to calculate those into our calculations, essentially. So the best way, I guess, to do that, so what we want is we want to essentially convert all of these final units mined to final storage space. So we go that multiplied by Umber cool. I think this will give us the final storage space here. And then we just drag it across. And then down to 278. See if that makes sense in terms of value wise. And then let's just do a sum. I guess that makes sense because we just want the 27,500. So how about total sum of asteroids? We have, and that's honestly, I'm pretty sure it's just this, right? There we go. And then just do the difference. Cool. And then let's just do the sum. So kind of going through this, I definitely did much more roundabout way of kind of calculating all of this, except we don't want the example one. So 259. And that should give us the answer for bonus 5. Okay, cool. So just to kind of go back, item 6, to calculate the total remaining leftover, essentially what ended up happening is we just calculated kind of the total of everything, like of all of the asteroids here, which we are technically already have, right? Because before we calculated the amount total storage of ore mined from the asteroid all the way across here. And so this entire sum is just this number right here, because we're summing across all 24 of the asteroids. So we're just taking these numbers and we're actually essentially just subtracting the fact that in all of the transport barges, it maxed out at 27,500. So we're just taking this number minus 7,500, adding it to whatever this times 27,500 is, and so forth. And essentially, that's just a calculation, an easy way to calculate kind of the remaining amount on the asteroids left. I think the tricky part of this question is it's actually a lot simpler than at first glance what you would think, because you would think that you might want to calculate the unmined amount of asteroid across all games without the mining waste, but it just used the mining waste. So the previous calculations there, this number I think should actually be a little bit higher, because technically we should account for the fact that all unmined asteroid ore should have no waste calculated across it, because technically someone with a better mining skill level can come to that asteroid and mine it out, right? But no, it's as simple as just taking existing calculations and plugging it in there. So that should resolve all of the case studies. And I think kind of just going through it, you can see that a lot of it just is very repetitive. Like you use similar calculations, but you just need to set up your data in a way that you can make use of kind of what you did in the previous levels in order to just solve each new level there. And so that, yeah, this is pretty much the case study. I think kind of talking through it and going through it took about maybe 2.5 hours, maybe a little bit longer to do. So it's totally reasonable to imagine somebody who's just kind of like rushing or going through it to try to figure it out in maybe like less than 2 hours, maybe an hour and a half, and that sort of stuff. But once again, though, like there's a lot of kind of minefields or things that like if you're going through it the first time, probably gonna fall into a couple of traps and kind of get stuck at certain points. And kind of just navigating your way out of those can be very tricky. So I would definitely say that this is one of the kind of I wouldn't say this is one of the tougher kind of case studies that Excel has done, but I would say that this is definitely one where there's plenty of places where it can hang up people who are trying to solve the case and that sort of stuff. So, as a general kind of summary, I think the most important aspects of this case are one, to understand kind of this asteroid type or unit volume, minerals contained in 1 unit of asteroid ore, and an asteroid like ore unit amount. Kind of that relationship you have to know well in order to solve cases 3 to 6. The other kind of main trick I would say for solving this is getting the background colors and essentially pulling kind of the asteroid background colors as well as the ship background colors in order to easily kind of access and kind of collect that data when it's given to you in a not super easily consumed form like here. And we can definitely see that like for something like case 7, you absolutely need to kind of programmatically pull what each of the background colors are so that you could grab the asteroids there. I think those are the two main tricks. Everything else really that was used here is pretty kind of basic to Excel, lookup tables, some products, organizing the information. I think maybe the only other thing, and we kind of got lucky, and I didn't really go back and revisit, is kind of this distance thing of so calculating the distance from this to any ore location was just as a simple matter of kind of getting kind of the longest distance, because being able to move diagonally gives you a lot of flexibility to get to the asteroid in question, and none of them really block your way. What would have been potentially much more devious and challenging would be if this asteroid field was more populated and you actually had to go all the way around in order to reach a particular asteroid. And in that case, doing something as simple as just calculating the difference in rows or columns would not have worked, and it would have either required manual solving or some sort of maze solving program, and that would be a lot longer to program on the spot on Excel. So I'm glad this essentially traversing the distance to the asteroids didn't end up being super difficult in this case. Yeah, with that said, that's pretty much all of this Excel Eve case in a nutshell. Hope you enjoyed, and if you like to see any more of kind of these cases in the future, or if you're interested, leave a comment, and I might do some more of kind of this Excel case work and that sort of stuff. But other than that, I just was really interested in this year's final kind of competition case and wanted to give it a shot myself to see how it was. It was definitely difficult, but kind of working through it, I think it's not overly difficult. That I think a lot of you guys can give it a shot. Maybe it'll help you learn one or two things about Excel, working with numbers and data and that sort of stuff. And just if it kind of appeals to you, by all means, have fun at it. Hope this kind of explanation and walkthrough of this case has been insightful. Hope we didn't bore you too much, and have a great holidays as it's coming up. So take care. See ya.